Hello everyone. Here I want to discuss a question on impulsive tensions. The question reads like this. There is a smooth inextensible string of length L tied to the supports A and B, which are in the same horizontal level and separated by a distance of L by 2. A small bead is released from A to move on its without any friction. The speed of the bead immediately after the string becomes tight is root GL tan 37 upon N. In this expression we have to find the N value from there. So I have imagined the situation like this. This is the string of length L. These are points A and B which are separated by L by 2 and bead is released from this point. Now when we release it, until the string becomes tight, there is only one force acting on it, which is gravity. So we can assume that it is going to have a free fall motion until the impulses are generated in the string. So from here, from the point of release, this is the situation where I have imagined just before the string is becoming tight, where it has fallen by a length y. Total length of the string is given as L, so this side I can assume it as L minus y, and according to the question this is L by 2. You can simply apply Pythagoras theorem in this triangle and you can get the y value as 3L by 8. So as it is falling freely for a distance of y, the velocity of the bob just before the string becomes tight is root 2gy. On substituting this y value of 3L by 8 here, you will be getting this expression. As the question has a tan 37 degrees term, instead of 3 by 4, I am just replacing it with tan 37 degrees here. Right? Now, if you observe the geometry of this, L by 2, 3L by 8, 5L by 8, you can easily get these angles as 37 degrees and 53 degrees. Now, when the impulsive forces started acting on the bob, you can see impulse will be generated in this direction, impulse will be generated in this direction. By symmetry, the net impulse will be somewhere in between this. This total angle is 53 degrees. So I can imagine this half angle is going to be equal to 53 upon 2 degrees. And based on this angle theta, I am taking the components of this u as u cos theta and u sin theta here. Now before discussing what is going to happen here, I want to discuss a simple case, similar one, and I will again come back to this one. So you may be already knowing this. There is a light string. When you release it in gravity, it will fall free. When the tension is developed, impulse is developed. This impulse will completely eliminate the component which is in the direction of the impulse, and there will be no effect on the component of velocity which is perpendicular to it, and it starts moving in a circle for an instance from there. So you can imagine instead of these two strings here, if we come back to this one, instead of these two strings, I can imagine only one impulse is acting in this direction, which is very similar to this impulse acting on this bead. So I can imagine whatever component of velocity is there in this j net direction, that will be removed by that impulse, which is u cos theta, and only this u sin theta will be left out with the bob after the impulse has been generated. So here I have written that the final velocity just after the string becomes taut is u sin theta, because this component will be removed by the impulse. U value we already know, as we have calculated here. You can substitute that value here. Theta is 53 by 2, so sin 53 by 2. I have done a simple calculation using sin theta by 2 as root of 1 minus cos theta divided by 2. You can substitute the values and you can check, it is coming out as 1 by root 5. So if I substitute 1 by root 5 upon here, taking that into one term, you will be getting this expression where this is going to be your n. There is an extension question to this one which I want to discuss in the next video. Thank you.